Hello all, welcome back to my YouTube channel all about VLSI. In this video, we are going to discuss about UVM driver. So basically, we have seen this driver in SystemVerilog also, but we are going to discuss how this driver is different from those in SystemVerilog and how we are using this driver in the UVM. Okay. So basically we already know in the SystemVerilog also the driver which is going to interact with your DUT. So a driver is a component which is going to interact with the DUT and it is going to convert the transaction level objects into pin level pin level data, and it is going to feed the DUT, that we already know. So it is going to drive the randomized transactions or sequence items to the DUT as a pin level activity using an interface. Basically we already know this, that the driver, it is going to drive the randomized transactions, or in UVM we are going to call them as sequence items. Okay, in further sessions also we are going to see them. Basically these sequence items are nothing but our randomized transactions. Okay, these are being converted into a pin level activity using an interface. So we are using an interface for communicating with our driver and our design. Now, so the driver has extended from the UVM component name as UVM driver. This we already know. So if you want a user-defined driver class that should be declared inside your Testbench, then you must extend it from UVM driver. Okay. The transaction or sequence items are retrieved from sequencer, and the driver drives them to the design using interface handle. Okay. So first of all, let us see this. Let's say this is our design. Okay. Let's say this is our design. Let's say this is our design, and let's say this design wants to be driven to data items, that is write address, write enable, and data in. Okay, so these are the things which our design should be driven. Okay, for example, I'm talking about a simple example. I'm taking a simple example. Okay, so this design needs three data items. Okay, one is write address, write enable, data in. Okay, so how the driver it is going to drive these data items. Now in SystemVerilog, let us talk about SystemVerilog. In SystemVerilog, we were creating a transaction class. So we were creating a transaction class or some class. Okay, we are creating some transaction class or any class which is holding this data items, basically which is holding this data items. So this in the transaction class, these are declared with the rand keyword, rand write address, rand write enable, rand data in. So in our transaction class, so this properties are declared as with the keyword rand. Okay, now using the generator class, I'm talking about SV. So using the generator component or class, what we are doing, we are basically having this transaction class instance inside our generator class. So we were having this transaction class instance inside our generator class, and using the transaction class instance, we are randomizing them. Basically we are performing randomization. And using this class handle. So these things are getting randomized, and after that what we were doing, using a mailbox, we are basically sending them. So tr.mailbox handle mbox dot put this tr. So basically using our mailbox handle, we are basically putting our randomized transaction data. So using our mailbox inside our generator, basically we are putting our randomized data and we are sending it from the generator, and this will be received by the driver. So in the driver class, basically we are receiving this transaction object. So we are receiving mbox.get of tr. So in the generator class, we were randomizing the things, and we are putting the object using the mailbox, and in the driver we were getting that particular object. And after getting that, what we were doing, we were using the interface instance inf dot write address, which is equal to tr dot write address. And what we were doing, inf dot write enable, tr dot write enable. So this we were doing. So basically what we were doing, we were using this write address, right? Basically we are passing the properties from the transaction class to the interface. We are copying them. Okay, this is the process which we were doing in SV. Okay, now in the case of UVM, this is not the process we are going to follow. This is not the process we are going to follow. So basically in the case of UVM, we are going to have two components. So one is our sequencer and another is known as our driver, and this is our DUT. So this driver and DUT are connected with our virtual interface. So this we already know. Okay, the driver and DUT are connected with our virtual interface. Now basically here the driver, it is going to drive the transactions or sequence items to the DUT as a pin level activity using an interface. So so in the case of UVM, we are going to have a objects which are known as sequences. So these are known as sequences. Basically this will come under the category of objects. Okay, so if you don't know what is objects and what is components, please revisit our previous lectures where we have categorized the classes into components and objects. In UVM we will have some objects which is known as sequences. So these sequences are nothing but it is going to have your data properties or the properties which the driver wants to drive to the DUT. Okay, what is this sequences, how we are going to declare them, that and all we are going to discuss in our further sessions. But for now what you need to understand is the sequences are nothing but these are going to contain the properties or the data which the driver wants to drive it to the DUT. Okay, now these sequences will be driven to our driver via the sequencer. So the sequences will be driven to the driver. The sequences will be driven to the driver via the sequencer. So using the help of your sequencer, you are sending your sequences to the driver, and this driver further send it to the DUT. Okay, and there may be multiple sequences in our test bench. There may be multiple sequences in our test bench. So there may be 3 sequences or 4 sequences, or there may be multiple sequences which are present in our test bench, and it's the duty of our sequencer to send these sequences to our driver, and driver will accordingly send it to the DUT. Okay, so regarding the sequences which we are going to learn it further. Okay, just for now you need to understand this sequences it is going to contain some data which is going to be sent via the sequencer. Okay, now so the driver has extended component, this we have already seen. So the transaction or sequence items are retrieved from the sequencer, and the driver drives them to the design using the interface handle. So that is what which we have seen. So the driver, it is going to get the sequences from the sequencer, and further the driver, it is going to drive the sequences to the DUT via this interface handle. Now this interface handle can be retrieved from the configuration database which was already set in the top level hierarchy. So how the driver is getting the interface instance, that we have already seen in our previous lectures, not exactly which we have seen, but we have studied about configuration database, right? So using the configuration database, the top is going to set the interface instance, and it is going to send it to the driver, and driver it is going to utilize it. In the case of SystemVerilog, if you remember, we were getting that interface instance to the driver via the top only, but using the new method. But here we are not going to use a new method for getting the interface instance, but here we are going to use a configuration database for getting the interface instance. So the driver, it is going to get the interface instance via the configuration database. Okay, so that is not our topic now. We are going to discuss how we are establishing the things, how we are establishing the connection between the driver and sequencer. That is our main motto. Okay, now so the UVM driver class is a parameterized class of REQ, sequence item, and RSP, sequence item. So REQ is nothing but request, and RSP is nothing but response. So REQ is nothing but request, and RSP is nothing but response. So what do you mean by sequence item? That and all we are going to discuss in our further sessions. A sequence item, it is also a class. Okay, that will be discussed in our later sessions. But first of all, please remember that UVM driver, it is a parameterized class of which type it has 2 parameters. One is of REQ, which is of sequence item type, and RSP, which is also of sequence item type. Okay, so what do you mean by sequence items? That are all we are going to discuss in our further sessions. And RSP, this is optional. Okay, so a driver can have only one argument, one parameterized argument, which is nothing but REQ. RSP is optional. Okay, so usually REQ and RSP sequence items have same class type. Okay, so this REQ and this RSP will be of same type until and unless if you declare them different explicitly. Coming to UVM sequencer, let us have a glance about what is this UVM sequencer. As we have already discussed, this UVM sequencer, it is a mediator who is establishing a connection between sequence and driver. Okay, what do you mean by sequence? That we are going to learn in our further sessions, and what do you mean by sequence item, that and all we are going to see in our further sessions. Okay, our main motto of this session is to establish a connection between sequencer and driver. Okay, so ultimately it passes the transactions or sequence items to the driver so that they can be driven to the DUT. So what and all the transactions or the data items that should be driven to the DUT by the driver will be provided via the sequencer from the sequence. Okay, I will repeat my point again. So whatever the data items or the transactions that should be driven by the driver to the DUT will be given by our sequence, via the sequencer. So the sequencer is a mediator which is establishing the connection between a sequence and a driver. Okay, so when I will discuss about sequence, then you will get to know, okay, what do you mean by sequence? For now, just remember that sequence is a object which is containing all the transaction items which your driver wants to drive it to the DUT. Okay, so basically this is going to pass the transactions or sequence items to the driver so that it can be driven to the DUT. Now, how to get the sequence items from the sequencer? Okay, that is our main target. Now, first of all, this sequence. So here the sequencer and driver, let us see the connection. So the sequencer and the driver are connected using TLM ports. So the sequencer and the driver are connected via the TLM ports. Okay, so the sequencer is having UVM sequencer, UVM. So basically it is having UVM sequence item underscore pull underscore export. Okay, so this is a port which a sequencer is having, and the driver is having UVM sequence item pull underscore port. Okay, so this is the driver port and this is the sequencer's export. So these are connected with each other. Okay, now so in the sequencer, like when we were discussing the TLM ports, there if we are declaring any class, there we have explicitly declared the handle TLM class, TLM port handle we have explicitly declared, but here there is no need to declare anything. Okay, so everything is predefined. So the predefined port handle in the case of sequencer is sequence underscore item underscore export. So this is the handle which is available in the sequencer. Okay, and in the case of driver also we no need to declare any handle. Okay, so there will be predefined handle which will be declared. You don't need to instantiate or you don't need to create any instance of any handle. Okay, like in the TLM ports, if you remember, if you haven't watched those TLM port videos, please watch it. That is a prerequisite. Okay, so there we have created the instance of our TLM port using the new method, but here this and all are predefined. So how what is the handle in which is present? Sequence underscore item underscore port. Okay, so these two are predefined. Handles. Okay, so these two are predefined handles which are declared. You don't need to create any instance of these handles. Okay, so using these handles we are going to see some. So these are the handles which they have declared. Okay, so how we are going to get the sequence items from the sequencer? This is our main question. Okay, so TLM is used by the driver of type. So the driver, it is going to use a TLM port. So the driver, it is going to use TLM. TLM is used by the driver of type UVM sequence item pull port. Okay, that we have already seen. to accept a series of REQ sequence items from the sequencer. Okay, so basically this driver, it is going to use UVM sequence item pull port for receiving the series of sequence items from the sequencer. So this sequencer, it is going to have a FIFO which is going to contain all the sequence items. So this sequencer, it is going to have the sequence items. So from this FIFO which is present in the sequencer, this driver, it is going to pull these items from the sequencer. Okay, so that is what it is written here. So the TM, it is used by the driver of type this particular port, and it is going to accept a series of REQ sequence items from the sequencer, and the driver can provide optional response sequence item back to the sequencer if required. So this is optional thing that we have already seen, right? Now coming to the driver methods. Now here the driver, it is going to pull the sequence items from the sequencer which are present in the sequencer's FIFO. So how this sequencer, it is getting the sequences? So from the sequence object, it is going to get it, sequence 1. Okay, so it is getting these items, and this sequencer, it is going to give it to the driver. Okay, now so there are basically two methods. So there are two ways to interact with the sequencer. So one is using get underscore next underscore item or try underscore next underscore item, and another is item underscore done. This is first method, and second method is using get and put methods. Okay, let us try to see how the driver is actually getting the data from the sequencer, how it is fetching the data from the sequencer. So first of all, let us see the first type of methods, which is get underscore next underscore item or try underscore next underscore item and item underscore done. So basically get underscore next underscore item, it is a task. So why we are using a task? Because it is going to have some delay. So since it is going to have some delay, we are going to use a task. Okay, so basically this get underscore next underscore item, it is having a argument of REQ item. Okay, now so it is a blocking method that blocks until REQ item is available in the sequences request FIFO. Okay, so basically how we are going to call this get underscore next underscore item is, so let us see the code for our driver, how to use this method, how to declare them. So let me declare a class driver. Now how to declare your driver class? So how to declare our driver class? So class UVM driver. So this is the built-in class which is available. So this is the built-in class UVM driver. It is a built-in class which is extended from the UVM component. So this UVM driver class, from this UVM driver class, extend our user defined driver class. Okay, so we are going to class driver, which is extending from UVM driver, and UVM driver, it is a parameterized class, so we need to pass the parameters. So what is the parameter which we can pass? So it is expecting a argument of UVM sequence item. Okay, type REQ is equal to UVM sequence item. Okay, so this we should pass. So let's say suppose if we have a transaction class, in SV also we have seen the transaction classes. Like let's say suppose this transaction class is going to have all the data properties which the generator sends it to the driver, and the driver further it will convert this object items into the pin level items, and it is going to send it to our DUT. Okay, so this is our transaction class. Okay, same, so in our UVM also we are going to declare one transaction class that is nothing but our sequence item. So here it is known as sequence item. Okay, so this class name we should provide here. So what is the name? Let's say suppose it is write underscore transaction. Okay, then what will happen? If we are passing write underscore transaction, then this REQ will be of type write underscore transaction. So this REQ will be of type write underscore transaction. So what will be the argument which is present in the UVM driver class? That will be of type write underscore transaction. So this REQ will be now write underscore transaction type. Okay, I'm writing here for your clarity. Now inside this we already know how to declare this, how to register this, that and all we know. Now let us see how to call this method. So within a run phase, task UVM underscore phase. So how we are calling this get underscore next underscore item? We have the port handle, we have the TLM port handle, which is nothing but sequence underscore item underscore port, we have sequence underscore item underscore port dot get underscore next underscore item. And what we are going to pass, we are going to pass REQ. So this is what we are doing. So what happens? So it is a blocking method that will block until the REQ item is available in the sequences request FIFO. Okay. So basically what is going to happen, the transaction which is present in the sequencer, so the transaction item which is present in the, or the sequence item which is present in the sequences, so the sequence item which is present in the sequences FIFO, that will be copied. So what happens when we are calling this get underscore next underscore item, basically when we are calling this method, that is going to wait for the availability of the REQ item in the sequences request FIFO. Okay, so whenever this item is available in the sequences request FIFO, this object will be copied into this REQ. So this object will be copied into this REQ. So whenever this copy has been completed, this task will be moved to the, so whenever this is available, then this will be completed. Okay, so that is what it is happening. This is in the case of, this is sequencer. So once again I will explain this. So what is happening is, when we are calling this get underscore next underscore item using this port handle, then we are passing one argument that is nothing but REQ. This REQ is nothing, it is of type write underscore transaction. So this is a handle of write underscore transaction. It is of type write underscore transaction. So whenever we are calling, what is this task doing? It is basically, it is a blocking method that is going to block until the REQ item is available in the sequences request FIFO. That already I have shown that sequencer, it is going to have a FIFO, and in this FIFO, until the REQ item is available, until the REQ item or the write transaction item which is available, so until it is available, it is going to block. So after it is available, then what is going to happen, this will be copied into this REQ, and this task will be unblocked. So that is what it is happening. Okay, now next, coming to try underscore next underscore item. So basically it is a non-blocking method that is going to return the handle of the REQ item. Okay, if it is available, it is going to return the handle of the REQ item, it is available, or else it is if it is available in the sequences request FIFO, or otherwise it is going to return null. For example, in this case, when we are using get underscore next underscore item, if the item is present, then it is being copied and it is returning that. Okay, basically this item is being returning. But when we are using try underscore get underscore item, it is a non-blocking method. So it is, if the item is available, then okay, it will return, or if the item is not available, it is not going to return anything. So that is what it is happening in the try underscore next underscore item. Okay, so this is basically blocking, and this is basically non-block. Now what you need to understand for now, if you are learning this UVM for the first time, what you need to understand for now is this, what is this sequence item which is present in the FIFO and what we are getting. Don't need to worry about anything. So basically we are getting the transaction items, we are basically getting the sequence items, or you can say basically we are getting the transaction objects from the sequence via the sequencer to the driver. That's it, that is what it is happening. Okay, yes. So when we discuss about sequence items in our next session, you will get a clear idea. For now, what you need to understand is how the driver, it is retrieving the sequence items or the transaction objects from the sequencer. Now coming to this item underscore done, it is a function. That means it should not have any delay. Okay, so coming to this item underscore done, it is a non-blocking method that has to be called after the get underscore next underscore item. After get underscore next underscore item, you should use this item underscore done. So or successful try underscore next underscore item, you should call this get underscore item underscore done after get underscore next underscore item, or you can also call this function after try underscore next underscore item. Okay, to complete the driver sequencer handshake. For example, if you have studied EHB protocol, there we are using HID signal for handshaking. Okay, so basically your sequencer also should know, right, you have the driver has successfully received the transaction or not. So basically it is a handshake signal. Okay, so it may pass response sequence item as an argument to place it in the sequencer's response FIFO. Okay, this is optional. Okay, don't need to worry about this, this is optional. So if no argument or null pointer is passed to the item done function, it can also complete the driver sequencer handshake. And this calling this function is mandatory. Calling this function is mandatory. So that if you call this function, then only next sequence item will be called or next transaction object will be called. If you are not calling this function, then it is not going to call the next transaction or sequence item. Okay. Now next, let us try to discuss about get and put methods. So basically this get method, it is a blocking method that blocks until a REQ item is available in the sequences request before. Okay. Any further calls to the get without put call will result a pointer for the next REQ item. So basically what is happening is, in the case of your get underscore next underscore item, if you are calling this, then the transaction item or the sequence item which is present in the FIFO will be written to this REQ. Okay. Now when will be the second item will be given from this FIFO? Whenever you are calling get underscore next whenever you are calling item underscore done, then only you can access the second thing. Okay, second transaction item. But in the case of this get method, so what we can do is, if we call this get method without calling this put method, so we will have one put method, it is similar to item underscore done. So whenever we are calling this get method after the second time without using this put method, okay, this put method is similar to your item underscore done. So what will happen? It will result to a pointer to the next REQ item. So basically, if you're calling this get method for second time also, it is simply going to refer to the second item which is present in the FIFO. Okay, it is going to retrieve that. Okay, but in the case of your get underscore next underscore item, until and unless you are using item underscore done, it is not going to retrieve the second item. Okay, but here if you are using get method, what is going to happen? It is going to retrieve the second item without it is going to retrieve the second item without waiting for any acknowledgements. And coming to next type of method, which is peek method. So it is a blocking method that blocks a REQ item if it is available, until it is available in the sequences request FIFO, and any further calls to the peek method without put or item done call will result a pointer for same REQ. It is also same as your get method. Okay, and coming to put method, so it is a non-blocking method that is used to place response item in the sequences response FIFO. So the put method is not connected to the driver sequencer handshake mechanism, hence it can call at any time. Okay, so there is no necessary that you should call this put method after this get method only. You can call this put method before the get method also. There is no dependency upon the handshake between. Okay, there is no handshaking. It is not involved in any handshaking mechanism. Now, what is the difference between your get underscore next underscore item underscore done, and get underscore put underscore approach? So basically, the item underscore done must be called after the get underscore next underscore item or successful try underscore next underscore item call. Then only the next sequence item can be requested. Whereas get call can request other request item even if put method is not called. That is what we have discussed just now. So the put call must be called with response sequence item as an argument, whereas it is optional for item underscore done. So in the case of item underscore done, there is no need to give any argument as response, whereas in the case of put method, you should always provide a response. So in the case of get underscore next underscore item or item underscore done approach, wait for item underscore done task, UVM sequence based class gets unblocked when item underscore done is called from driver once the transaction or driver. So this third point we will discuss after discussing about UVM sequence. Okay, then only this particular third point will be clear. Now if I want to summarize the things, then you can just assume this UVM sequencer which is having a simple FIFO where it is having multiple sequence items or transaction objects, and if you want to retrieve them, you are going to call get underscore next underscore item. So if you are calling this get underscore next underscore item, basically you are retrieving this transaction item or the objects which you are retrieving them one by one. Okay, and you can retrieve the second object whenever you are using this item underscore done. Whenever you are using this item underscore done, then only you can able to retrieve the second item. But if you are not using if you are using get method, then what is happening is there is no need to use put method, which is a response method. Okay, there is, if you are not using this and if you are calling the get method again, then you can just simply call the second item, and if you are using it for the third time, then you can call it for then you can retrieve the third item. So this is how you are retrieving the data from the sequencer. And how the sequencer getting the data? The sequencer is being getting the data via the sequence. This sequence is basically sending you the data. This sequence we will learn in our upcoming sessions. Okay, so this session agenda was to discuss about your driver and sequencer connection and how these are communicating with each other. Okay, yes, and where are this driver and sequencer are being connected, and coming to the connection of this driver and sequencer. So this driver and sequencer are connected in the agent. Okay, so this driver and sequencer are connected in the agent. Okay, yes, so that is how we are going to establish our connection and how we are going to communicate our driver and sequencer with each other. Yes, so that's all about this particular session. So if you like this video, please like, share and subscribe to my YouTube channel all about VLSI. Thank you for watching this video.